8.2. This is two-dimensional figures. So these are figures in a plane, and so let's go ahead and start talking about. We're going to talk about their simple closed curves, and these are curves that you can trace it in such that you never touch a point more than once. So if I'm looking down at these figures 1 through 13, number 1 is not a simple closed curve because we cross it. It crosses ourselves. Whereas number 2 is a simple closed curve because we never touch a point more than once. Is a simple curve. Closed means that if you trace it, then you start and stop at the same point. So number 1 is actually a closed curve, it's just not simple because I can start and stop at the same point. Number 2 is a closed curve, but it is simple because I can start and stop at the same point. A simple closed curve puts those two things together. So in other words, I start and stop at the same point and I never touch a point more than once. And simple closed curves are what's important. These are what we're going to look at. These are what most quadrilaterals are. Most of the things that we care about or that we use as figures that we talk about, two-dimensional figures, are simple closed curves. So examples of simple closed curves are 2, 3, 4, 8, 9, 11, and 13. Now, something that is not closed is 5, 6, 7, and 10. Not simple are 1, simple being that you never touch a point more than once. 1, 5 is not simple. 12 is not simple. 10 is not simple. Okay? So the simple closed curves are 2, 3, 4, 8, 9, 11, and 13. And those are the important ones. Those are the ones we're going to look at. The Jordan curve theorem says that if we have a simple closed curve, partitions the plane into 3 regions. So that is the curve itself, so that's the black line, the interior, which is what is inside, and the exterior, which is everything that is outside. So if you look at one of these on the sheet of paper, the interior is everything that's inside. The exterior would be every part of the paper that is not inside the curve. And then the curve itself, which is the black line. A polygon is defined as a simple closed curve in a plane that is composed only of line segments. So if I go back up here and I look at these figures, 1 through 13, the polygons are 9, 11, and 13. 3 has curved edges. 2 has curved edges. And 8 has curved edges. And so 4, 9, 11, and 13 are the ones that are polygons because their sides are line segments. Where 2 sides meet is called a vertex, or plural is vertices. A line segment is called the side. A polygon with 3 sides is called a triangle. There are properties of triangles, and we're going to talk about A through F, and then we're going to classify some triangles next. If all the sides are the same length, that is an equilateral triangle. These definitions of triangles are very important. Okay? Property of equilateral triangle are that angles opposite congruent sides are congruent. In other words, that if all the sides are congruent, then all the angles are congruent. Okay? The angle bisector of any angle forms 2 congruent sides. In other words, the angle bisector is also a perpendicular bisector. It's more than that. It's a perpendicular bisector to the other side. If at least 2 sides have the same length, then it's isosceles. The angles opposite those congruent sides are congruent. So if I look at this as the base being the side that is not the same as the top as the other 2 sides, then the base angles are congruent and the sides that come down from the top vertex are the two sides that are congruent. The angle bisector of that top angle is the perpendicular bisector. So if I have the two sides congruent, the angle that is between those two sides is the one that the angle bisector of that angle is the perpendicular bisector. If all three sides have different lengths, then no sides have the same length, then we say that no angles are the same, and that is a scalene triangle. Now remember, the sum of the angles in a triangle are 180 degrees. We define a right triangle as a triangle that has one right angle, and it can only have one right angle. An obtuse triangle is a triangle that has one obtuse angle. I have had students tell me that an obtuse triangle is a triangle with all obtuse angles. Well, that can't be true. If the sum of the angles of a triangle are 180 degrees, and I have one angle that is between 90 and 180, then the other two angles have to be acute. That means they have to be less than 90 degrees. I can only have one obtuse angle in an obtuse triangle. An acute triangle is a triangle that has all three acute angles. So now let's classify each of the following. The first triangle is equilateral, and it is an acute. All equilateral triangles are acute triangles. They are the same. An isosceles triangle, and it's acute for the second one. The third is an acute triangle. It's also a scalene triangle because none of the sides are equal. The third is a right triangle, and it actually is an isosceles right triangle. The second row, the first one, is a right triangle, and it's a scalene triangle because none of the sides are the same length. The next is an obtuse triangle and a scalene triangle. And the last is an obtuse triangle and a scalene triangle. And so those are 7 triangles that we have talked about. Next, when we position a triangle so that one side is horizontal, we usually call that side the base. The height is the perpendicular distance from the base to the vertex opposite. So, if you notice in the first triangle, the height is inside the triangle. So I have a base and it's perpendicular up to the vertex opposite. And in the second triangle, that's an obtuse triangle. I think they're both obtuse. They're just different where you put your base. Notice that the height or the altitude, and altitude and height are interchangeable. That the height is outside the triangle. So you don't always have to put the height inside. Next is that the sum of the angles of a triangle are 180 degrees. And a median is a line segment that connects the vertex to the midpoint, which is the middle of the other side. This is not always perpendicular. It is only perpendicular if my triangle is equilateral or isosceles, and I'm at that particular vertex in an isosceles. And there's a picture, and we will use medians a lot when we get into the appendix material, which is the next set of material. An angle bisector is the line segment that bisects the angle of a triangle. This can be it can bisect any angle. I'm showing it from one angle. If I have, excuse me, if I have that AB equals to AC, so in other words, if I have an isosceles triangle and I'm bisecting that angle, then I know that that line segment AD is perpendicular to BC and that it's a bisector. So that means that BD equals CD and that D is the midpoint of BC. A perpendicular bisector is a line that goes through the midpoint of the side and is perpendicular to that side. An altitude is a perpendicular line segment that connects a vertex to a line containing the opposite vertex. This is also called the height. Height and altitude are the same thing. Now, we have special points, and I call them special points, and you'll need to know these definitions, especially for the appendix material, which is the next set of material. One is the median, which we've already talked about. The next is the intersections of the median. This is called the centroid. This is also known as the center of gravity. Imagine that you have a triangle and you want to balance it on the tip of your finger, that you have a piece of paper that is the triangle and you want to balance it on the tip of your finger. That point at which you can balance it perfectly, that is the center of gravity, and this is the intersection of the medians. The intersection of the angle bisectors is called the incenter. So this is the center of the circle that lies inside the triangle. So if I want to put a circle inside the triangle, I'm going to use the intersection of the angle bisectors to find the incenter. The intersection of the perpendicular bisectors is called the circumcenter. So in other words, if I want to put a triangle around the outside of any figure, so around a triangle or a hexagon or whatever, where it hits all the vertices, then that is the intersection of the perpendicular bisectors. That is called the circumcenter. Now let me say this. The incenter will lie inside the triangle, okay? The circumcenter does not have to lie on the inside of the triangle. The circumcenter could be outside of the triangle. The intersection of the altitudes is called the orthocenter. Except for equilateral triangles, all three of these are different points. Now for equilateral triangles, some of them are the same point. We say that two polygons are congruent if and only if all pairs of corresponding parts are congruent. So that means that if polygons, now this could be squares or whatever, but right now we're going to just talk about triangles. So if I'm talking about triangles, that if I have all three angles congruent, then the two triangles are congruent. If I have two triangles and their angles are congruent to each other, then those triangles are congruent. If their sides are congruent to each other, then they're congruent. Now we have other ways of showing, we have 4 ways of showing that triangles are congruent. Side, 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 so that means that all the sides are congruent. Side, angle, side, so that means a side, then the angle in between two sides, the second side. So if I have two sides are congruent and the angle in between the two are congruent, then the two triangles are congruent. Angle, angle, side. So if I have an angle, then another angle, then a side are congruent, and then the two triangles are congruent. Or angle, side, angle. Now, notice that I have that you cannot do angle, side, side. And I have a note that says that if you can't say it, so remember, you're going to be teaching middle school students or high school students, depending on where your certification is, or elementary school students. If you could not say it in your classroom, if you got fired for saying the word in your classroom, then you cannot use it to prove congruency of two triangles. Okay? And I will show that in the examples when I go through the proofs. I'll show one of those that shows that you can't do that. Next, we're going to have a big list of definition of quadrilaterals, okay? And I'm going to just real briefly go through this. Now, let me say this. 90% of this test is going to be definitions and properties. You have to know these definitions and you have to know the properties of each of these figures, okay? So, FYI, if you don't know this, you're not going to succeed in this class. My advice is to go get some 3x5 cards and put this information on 3x5 cards, okay? A quadrilateral is a polygon with 4 sides. Now remember, the sides are line segments. They are not curved. The first one is a trapezoid. A trapezoid is defined to be a quadrilateral with at least one pair of parallel sides. Now, I've given you 3 examples of trapezoids. All 3 are valid. The first one is an isosceles trapezoid, where those 2 sides that are not parallel are congruent, and it has additional properties. Okay, and I'm not going to read through all this. I'm assuming that you're in college and you can all read. The second is a parallelogram. This is defined to be a quadrilateral where both sides are parallel. Now, I've given you an example of a parallelogram and where to find the height. Now, remember, the height or the altitude could be outside the parallelogram. Again, there are the properties, and I'm going to let you read through that. A kite is defined to be a quadrilateral with two pair of adjacent sides congruent. Now, I've given you two different pictures of a kite. I've also drawn in the diagonal for the first one. I've drawn in both diagonals. For the second one, I've only drawn one diagonal. And the first one is typically what we think of for a kite, but you've got to remember that a Pac-Man type symbol is where the sides are not curved but straight, is also a kite. A rhombus is defined to be a quadrilateral which all sides are congruent. A rhombus is what a baseball field is. Okay, so it looks like a kite, but it's more specific because all the sides are the same length, whereas in a kite, they don't have to be. A rectangle is defined to be a quadrilateral in which all angles are congruent. Notice it does not say that the sides are congruent. It says that the angles are congruent. This is the first one that has all angles congruent. Actually, all angles are 90 degrees. Because they're all congruent, we'll find out later that they all have to be 90 degrees. A square is defined to be a quadrilateral with four sides congruent and four angles congruent. Now, let me say this. You need to understand these definitions, and you need to understand the difference between how it's defined, what the definition is, and what a property is. So a square is defined to be all sides congruent and all four angles are congruent. The following are a list of properties of squares. Those are things that we will prove. Okay, we will prove some of these properties. A property is something you prove. A definition is something you know. You cannot prove the definition. That is what it is defined to be. Whereas a property is something you will use the definitions to prove. Okay, and we will do some of these proofs. Diagonal is a line segment that joins two non-adjacent vertices. So in a parallelogram, I have one diagonal because the others are adjacent. In a trapezoid, I have one diagonal. Notice that in the octagon, I have 1, 2, 3, 4, 5 diagonals. And I think that's a nanogon, and I'm just guessing. I'm not going to count through it. And so notice that I have n minus 3, isn't it 3? Diagonals. And the reason I'm telling you this is n being the number of sides, minus 3 because I don't include the point that I'm starting at or the two adjacent points. So it's n minus 3. So if I have a decagon, which has 10 sides, then I would have 7 diagonals. All right. Next, the relationship of quadrilaterals. You have to know this hierarchy, okay? You must know. We will have a lot of true or false that'll say every rhombus is a kite, true or false? True. Every rhombus is a trapezoid, true or false? True, because definition of a trapezoid is it has at least one set of parallel sides. A rhombus has 2 sets of parallel sides because it's a parallelogram. Okay, so you have to know this. So the more general stuff is on top, it goes down to the more specific. Okay, every square is a kite. Yes, every square is also a trapezoid. But every trapezoid is not a square. All right. Convex and concave. Concave means that it caves in on itself. Okay, we're going to be more concerned about convex polygons, but we're going to want to look at concave also. So there's an example. Convex are pointing out. Concave means it curves in. A regular polygon is one in which all the sides have the same length and all angles are the same. Now, at this we're talking about, so a regular polygon would be a square when we're talking about quadrilaterals. That is the only quadrilateral that is, I'm sorry, it's not. A regular polygon would, yes, the only regular quadrilateral is a square because a rhombus doesn't necessarily have the same angles. Okay, but we're also talking about regular hexagons, regular pentagons, regular octagons. Okay, so when we're talking about regular polygon, we're not just talking about quadrilaterals now. We're talking about n-dimensional figures, that they have to have the same side length and the same interior angles. The sum of the angles of a polygon with n sides is equal to 180 times n minus 2. The central angle of a regular polygon consists of the vertex at the center of the polygon. So if I intersect all the diagonals, that place where all those diagonals intersect is called the center angle. The sum of the exterior angles of any polygon, I don't care if it's a hexagon, quadrilateral, an octagon, the sum of the exterior angles is 360 degrees. The measure of an exterior angle of a regular polygon is 360 divided by n. Okay. The sum of the interior angles is 180 times n minus 2. Now you can go and you can use the sum of the exterior angles and prove the sum of the interior angles. And I don't remember if I do that later or not, but we'll see. The measure of an interior angle is 180 times n minus 2 all over n. Now, for me personally, I only memorize the measure of the exterior angle, and if I want to find the interior angle, then I take it from there. So if I know that the sum of the exterior angles is 360 degrees, and I want to find a specific exterior angle, I'm going to divide it by n. Then to find the interior angle, I'm going to subtract that measurement from 180 degrees, which is going to give me the interior angle, and then to find out how many there are, I sum those up. So I multiply that by n. Now this is a nice little chart. You can memorize it. I usually just find it. I don't try to memorize it. So it tells you the different types and the number of sides. So a triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, so forth. It tells you the central angle, the sum of the exterior angle, which is all the same, doesn't matter what kind of figure it is, it's always 360. The exterior angle, the interior angle, the sum of the interior angles, and the number of diagonals. Now, this is for regular polygons, okay? So, not every triangle is going to have an exterior angle of 120 degrees. Only one that is going to be a regular triangle. What is the name of a regular triangle? Well, regular being that all sides are equal and all angles are equal, and the only one that fits is an equilateral. Okay? The number of diagonals of an n-gon from a vertex is n minus 3 because there are 3 vertices that aren't counted. So if I want to find the number of diagonals, I'm going to multiply that by n, and then I'm going to divide it by 2 because if I multiply by n, then I've counted each diagonal twice. Okay? Next, let's talk about circles for a minute. Let me take a deep breath. I feel like I'm running through this. Let's talk about circles for a minute. A circle is a set of all points in a plane. A circle is the set of all points in a plane that are the same distance from a given point. Okay? In a plane is key here. I've given you an example of where the center is, where a chord is, the diagonal, the radius, and a tangent. The radius is the line segment from the center to any point on the side. The diameter is the line segment that has 2 endpoints on the circle, but it goes through the center. A chord is any line segment with endpoints on the circle. So a diameter is also a chord. A tangent is a line that intersects a circle with exactly 1 point. An arc is the subset of a circle, and we use the little curve over the 3 points that involves. You label an arc with 3 points. The equation of a circle is given by r squared equals parentheses x minus h close parentheses squared plus parentheses y minus k close parentheses squared, where hk is the center. And you need to know that. You will have to memorize that formula. It will not be given to you. Coordinate geometry. So this is basically using grids, using normal, what you would graph, Cartesian system. The center is the origin, which is at 0, 0. We divide it into 4 quadrants. We label those quadrants counterclockwise. The first quadrant has points that are positive, positive. The second one are minus positive. The third are negative, negative. The fourth are positive, negative. We always label them as x comma y. X is the horizontal, y is the vertical axis. Other formulas you need to know: the distance, the slope, and the midpoint. There's the distance. It's the square root. So if you go back, if I were to square the d in the distance formula, notice that that is the equation of a circle, where the center would be x1, y1. Okay, I've given you an example of the distance. The slope is the change in y over the change in x. So that's y2 minus y1 over x2 minus x1. The midpoint is I add the two, I find the average between 2 points. So add x1 plus x2, divide by 2. I add y1 plus y2 and divide by 2. The last thing that you need to know are perpendicular lines have negative reciprocal slope and parallel lines have the same slope. Now let's do some examples.